meet today, and GTI is a great platform for enabling innovation. And just arrived from Sydney, Australia. I'm European, Italian actually, and I served two main companies through these years. I worked for Nokia for around 15 years, and then to Huawei around 10 years, and I was the head of the Center Research East Huawei Europe. Then I moved to Australia, Sydney. I joined Rakuten 4 years ago. I initially served as Chief Information Security Officer for Rakuten Symphony, and then I moved up into the organization. And now I'm heading the next generation advanced research division within Rakuten Mobile. Rakuten Mobile is a mobile operator in Japan, and it is the most advanced network in the world, rolling out an end-to-end virtualized infrastructure. So what I present today are my views on how we will become cloud native and AI native by design thinking of evolving our mobile communication systems to something more malleable. Are we there already in terms of cloud native and AI native? I think we are not there yet, and thinking of cloud native, there are still many challenges. By the way, cloud native means that your applications have been conceived, created in a way that they can run on cloud infrastructure, not on monolithic hardware. So the main challenge I have identified why we're not there, and Rakuten Mobile remains one of the few operators globally being fully cloud native, are the following. And I think the main problem is around the architecture complexity, how we carry along the legacy system, how we integrate them, work for readiness. I can tell you, shifting from telco to cloud is a very hard journey, because Telecom, they have developed their skills on monolithic architectures, whereas cloud demands for a completely different stack. And then I think that the other challenge is the understanding how to deploy the AI capabilities, as well as how to achieve computational efficiency. Those are the main challenges to become a system truly cloud native, thinking of 5G but also 6G. And then thinking of AI native, I think it's even more challenging, and there are some main reasons for this. If the first reason is the waste. I don't know how many of you played with AI, and I am one of them. And when you find out that you're not using your GPUs, you get really frustrated, because you see that GPUs, AI comes at a massive hardware and energy costs. If you're going to buy a GPU, for instance, it costs more than 10,000 euros. So like there are the latest technologies that go about 33 kilo US dollars. And then the energy consumed by the GPUs is extremely high. So when I hear speaking about AI, use energy of 5G makes me laugh, because that means you don't understand how AI works. When you see that to run AI models, and we demand for servers with 120 kilowatts each, then you end up in a very expensive, extremely expensive communication system. And your data center will require up to 100 megawatts to power them, which means the integration with a nuclear power plant. So this is the reality. It's not the one you run on a laptop. If you want to distribute AI as electricity, which I think is going to happen, these are the numbers we are facing. How we get there? So that's my vision. I design all networks, so I started from 3G, then I moved to Finland. In the Nokia, we designed 3G, which is a flop, by the way, and then we moved to 4G, and then the 5G with Huawei, and now we are on 6G. Today we are here. You can see that we are struggling to bring the 5G virtualized, so we define through XC, the virtual network functions, and now we think them to shift them to virtual machine, which is a technology we don't want, to a containerized infrastructure on Kubernetes, which is a distributed operating system. There are many workarounds to achieve that goal. You may think of the massive investment on FEO, followed by Forge and Silver. All of them are addressing the problem of automation. So how can I alleviate my pain to have this old design of network functions to run on my cloud unified platform? Are we there? No. So these are just artifacts for slightly improving the pain we are having today to onboard these network functions on a unified platform, cloud platform. So what I think should happen is that to shift from this kind of architecture with many workarounds to something that will look like this. That means that our functions will be cloud native by design. So when I think of bringing connectivity across my entire communication system to the end user, I need to think that that particular workload needs to run on the cloud on the exact same platform as the run services that make me monetize. By the way, Google Vision 30 years ago, 25, something like this, was communication should be offered for free. That I think is the right vision. We have to get there. Because through serving only communications, there won't be any kind of innovation. The system is already been saturated. To achieve this goal, we need to have my network functions on the same level as my services and MIIT on exactly the same platform. That's the system that finds cloud native and AI native by design. This will enable us to integrate the services of 6G with AI seamlessly because they're exactly in the same clusters, in communication through service mesh. I don't need even the connectivity we are having today on mobile systems. I can easily link them as you link your application, your laptop. And then run them on a Kubernetes and plug in that corresponding evolution on a unified cloud infrastructure powered by eBPF. eBPF, I represent you, stands for Extended Packet Filter. It is a virtual machine kernel that provides an instrument that we can modify the kernel to achieve advanced networking observability and security. So how we get there? Let us have a look at two ecosystems. The first ecosystem is on the cloud native, open source, and the other one I will show you how AI is evolving. There are many massive initiatives, and I particularly appreciated the effort of Orange and Vodafone. Orange extremely active across various projects, and Vodafone share exactly the same vision we have in Japan, or we have in general, among the operators that are going to the journey of virtualizing entire infrastructure. If you look at there, I can't read there, it's not reading well, but they're shifting from 2G, 3G, 4G, and 5G, and then to 6G, where we're expecting the deployment of the network only through simple Kubernetes commands. Like deploy my new workloads, providing connectivities, and then patch it just one single command. That's what I want. I don't want to change the feature and then buy new hardware, or even from generation to generation buy new hardware. I don't want to do that. I want to exactly install and run my 6G on where I'm running my AI services, because through those services is where I'm monetizing and very little to connectivity. Other initiatives you may see here around the core network and then across the entire infrastructure, and Essadon in the middle there has been just created as a project, and they are now studying the entire stack of the AI. So from the models to the data pipeline down to the management of AI itself, including, say, the regulatory framework. About the AI open source ecosystem, when we talk AI, it's not about models. So if you after your AI, you make it at scale, the stack you need to be in is extremely convoluted. This is where I work, this is where my organization works. The stack is represented over there, where you can see from model center to data center. So you can see you need to go across a completely different stack we are having today to run these sort of applications. You need to integrate models, especially model running on the cloud through APIs, And then you need to have machine learning operations and orchestration frameworks, such as RAID, because ultimately you want to run your AI workload on Kubernetes. You need to make them scalable. You need to reuse your infrastructure. You need to reuse your GPUs. So you need to run on a distributed operating system. And there you see all the steps that you have agent orchestrations. You need to introduce guardrail. You need to have a new way of observing your networks, address vulnerabilities of agentic workflows, and so on. Even the open API, another frameworks there, where we intend to open the network infrastructure, will deal with that particular framework, integrating through the model control plane, which is a new protocol that will enable the communication between AI agents. Here you also have an example, because if we shift from models to data-centric, from data-centric we shift to system-centric, ultimately we will deal with multi-component AI centers. And here you have an example of agentic AI workflows, different type of applications using the N8N, which is a framework that allows you to build this kind of capabilities on your infrastructure. So these are the two main ecosystems around cloud native and around AI native. Now, what I think the AI evolution is, not only me, but it's also Jan Lejeune and other top scientists in the world that share exactly the same opinion. I think that language model, they are at sunset. So if you look at their performance, they haven't improved recently. And the intelligence represented by a language represents only less than 5% of what we're having. Now, thinking that LLM have already ingested all the information we have created since existing on this planet, basically that knowledge is already acquired by a 4-year-old child. Language model, very limited. They cannot plan, they cannot reason. If you believe they can, you have not understood anything of the world. They can discuss about that. So they have to evolve. There are many workarounds which are, anyway, components, but do not solve the problem. You are having massive work coming with Meta. One is the Meta large console models, and the other one Meta chain of thoughts, which are all workaround to use language model. Improve performance, yes. Resolve a problem, no. Why not? Because we need to have a different way of modeling intelligence. By the way, intelligence means ability to acquire knowledge, process knowledge, and make decisions. In order to do that, we need two new models. So we are now shifting from language model to world models, which means we need to have a way to represent how the world functions, works. And how we do that? We use models that observe how the world works. And you have examples here from Google and then NVIDIA, but I'm particularly keen on promoting the GPA, because I'm here using my organization, my team, it works extremely well. So GPA stands for Joint Embedding Predicting Architecture. How does it work? It works with embeddings. It works with basically with a hidden state. And what GPA does, it makes a prediction of a representation of the future based on representation of the present and the past. So predicts a representation, exactly how it works our brain. Our brain predicts based on two things, based on action and actions and perturbation of the model of the object we observe. And that's how GPA works extremely well. Now, what I think are the main applications of GenAI to 6G are simply three. And the first one is around compression and semantic communication. Because when we create the hidden space, the latent space, that is a lower dimension than the original data. So that enables me to transfer data by consuming much less bandwidth. The second is ability to generate synthetic data and events, and generate them, so I don't need to obtain the data, because one limit of AI is the lack of data, up and down true. The limit of AI is energy, not data. Data can generate. And then the last application, which I think is extremely important, using JPA, will be the prediction of relationship between variables, which means learning embeddings, not real data, that predict the relationship between variables without reconstructing the data explicitly themselves. Okay, maybe last 2 words is about eBPF. This is a fundamental revolutionary technology coming with the Linux kernel. Initially, it's about 10 years, and now it's available on Android and Windows. This is a virtual machine that allows us, as operator, as a service provider, to program the Linux kernel, which means the real brain of any system, and achieve 3 main use cases: security, observability, and networking. More than 50 companies and organizations globally are using eBPF, and massive acquisition recently in Google investing 32 billion on WIPs. It's amazing. And that this is exactly one of the topics I am studying, developing, and deploying within my organization, Telecom Mobile. We have developed a platform denoted as Sauron eBPF, and through Sauron, across our entire virtual networking infrastructure running all on cloud end-to-end, that's around the mobile infrastructure. We have more than 3,000 4H nodes, and then we have 2 to 3 central data centers, and then around 40 plus near edge data centers and regional data centers. We have Sauron, so our eBPF agent all over the places, and through Sauron we can measure end-to-end, hop by hop. We can observe anything that crosses our network, and also we can achieve runtime security. And we have output 2 important documents. I think this is one of the most referred documents on Earth. It was downloaded more than 11,000 times in a year, which present more about our solution. And I'd like to conclude with some suggestions on what I think it is necessary for us to realize the vision of share, which means application, cloud native function, AI truly cloud native. First, we need to start shifting from the language model to JPA type of architectures, which will allow us for semantic and contextual better understanding. That's the first thing. So get out from language model. The second, we need to make AI business viable. It is not, because GPUs are extremely expensive, it's a waste. How to achieve this? There are many technologies we work in my organization. One is virtual, and it's a vertical product to scale it, so we can scale the resources we provide to the different workloads. We can share GPUs through a DRA, and also we can compose disaggregated infrastructure so that I can share my hardware among nodes within the same cluster, different clusters. And then I think we need to start using eBPF, because that is truly a revolutionary technology. We also need to recognize, that's very important, that 6G as a concept, you can read it through. It's nothing new compared to my talks 15 to 20 years ago at the European Parliament. Does not bring nothing new. Go to YouTube, search my name, and watch my talk at the European Parliament when I was running the census of Huawei. Today we're still not there. So we need to recognize that as a concept offers extremely little novelty, unless it's going to be integrated with a cloud-native architecture, technology, innovation, people. And I gave you today the journey, or the day I gave you the journey to get there. And finally, that's the most important thing. We work too much on standardization. The world does not evolve through standards, because innovation is not across the interface. Come to me with your close interface, be cloud native. I buy you. Who cares to open the interfaces as long as you provide services on my infrastructure, which I can use not only to provide connectivity, which has to be for free, but also other services that dare to be integrated seamlessly. So with this, I invite you to come to Sydney and join us so we can resume these conversations and realize this vision together. Thank you for having me today.